Welcome to the session on signals and system. With a small disclaimer, I am going to start with the video. So in this video, I am going to talk about the basics of signals. I am going to talk about the properties of the signals as well as the classification of the signal. So these things are important. The miscellaneous one is filters. So in the case of filters, I will be discussing with respect to IAR filter as well as FIR filter. So the assertion and reasoning questions, if they are asking, that questions will be based on this one only. So let us talk about why we are going for a discretization of a signal. Say suppose we are having an analog signals, nothing but all the environmental signals are analog in nature only. So even though we are having analog signal, what is the need for going for digital signal? Or in order to convert the analog signals to digital signal, we have to get into discrete signal, or we have to discretize the signal. What is the necessity for going from analog to digital is the big question. Now, in the case of analog, if you are thinking, storage space is infinite. Nothing but each and every closed samples you are going to store in the case of analog. But in the case of digital, it is not the scenario. What you are going to do, what you want, that one only you are going to store. So, storage becomes easy if you are going for discretizing. If you are going for discretizing the signal, nothing but storage becomes easy. Nothing but less samples is required or less memory size is required in the case of digital. Now what is the second advantage? If I want to multiplex the signal, multiplexing becomes easy in the case of digital. So storage space you are going to reduce and multiplexing becomes easy. So what you are going to do is, in the case of analog, what I thought, so all the processing will be in the case of digital domain. You are in need of A to D converters and D to A converters. Here, what is the first step you are going to do is, you are going to sample the data. What do you mean by sampling the data? You will be having the continuous signal, that is x of t, with the help of some time period. What you are going to do is, or with the help of some sampling period, what you are going to do is continuously you are going to sample. Sample in the sense of what? Open the switch, close the switch, open, close, like that you are going to do, and you are going to get the values of at 0, at 1, at 2 and so on, right? This is in the case of real scenario. But say suppose at t equals to 0, before to that, what is the value? It is -1, -2, -3 and so on. But for analyzing purpose, I am going to take n as plus or minus value. So this is how you are going to convert a continuous signal to a discretized nature. And here TS refers to sampling time. Now in the case of control systems also we have studied, we will be having some test signal, unit step, ramp and parabolic and even impulse also. So these things are your test signals. So similarly in this case also we will be having test signals. So the first one is, we need to talk about the characteristics or how you are going to define unit step. Unit step you are going to write it as u of t. Unit step is u of t, right? So if I am representing a signal, the signal will be like this. Now you define what is u of t with respect to time period. U of t equals to 1 for t greater than 0, 0 for t less than 0. Can you tell at t equals to 0 what is the value? T equals to 0, it is actually half. What exactly you are getting is, sudden raise you will not be getting. You will be getting a ramp kind of thing. Anyway, at t equals to 0 minus the value is 0, at t equals to 0 plus the value is 1, you are going to take it as average. But few textbooks, what they would be writing is, for t greater than or equals to 0, they are going to write it as 1. Again, it's a myth. So for t equals to 0, the value is half, and the amplitude you are going to take it as 1. So this is how unit step is defined. Now if I am talking about unit step in the case of discrete domain, it is u of n. This value is 0, 1, 2, 3 and so on. So at t equals to 0, the value is 1. At t equals to 1, the value is 1. At t equals to 2, the value is 1. At t equals to 3, value is 1, and so on. Remember one thing, in the case of discrete domain, it is 1 for n greater than or equals to 0. At 0, the value is defined in the case of discrete domain. But in the case of time domain, they are not defined. So you're going to take it as average and then you're going to solve. And 0 will be for n less than 0. This is one thing what you have to remember. Next is, let us talk about rectangular function. Next, let us talk about rectangular function. This rectangular function, you are going to call it as a gate function. Rectangular function, or you can also call it as a gate function. So in the case of rectangular function or gate function, the mathematical expression will be a rect of t divided by capital T, or it is a pi of t divided by capital T. How are you going to represent? Say this is my time period and the signal value will be from minus t by 2. The signal value will be from minus t by 2. So the signal value will be from minus t by 2 to plus t by 2. Only in this range the signal is defined. Having an amplitude of a. Next, so this is how you are going to define a rectangular function or gate function. And this is how you are going to define the impulse function. This is how you are going to define an impulse functions. Next one is continuous impulse. The next one is continuous impulse or direct delta also. So how you are going to define this one? So this is defined as an impulse. So how you can define an impulse? At t equals to 0. At t equals to 0, you will be getting an infinite value. So delta of t, which is equals to infinite at t equals to 0. But at t equals to non-zero, whenever t is non-zero, output value should be equals to 0. Nothing but a response you should get only at t equals to 0. Practically, is it possible? No. What you're going to do is, you're going to take a gate pulse. You're going to take a gate pulse. You're going to compress it. Still compress. What you'll be getting is, you'll be getting a curve which is something like this. Or you are getting a signal which is like this. So, say suppose, if this width is 2 and if this length is 1, upon compressing, what I'll be getting is width equals to 1 and the length will become 2. Nothing but area I'm maintaining constant. So still if I'm compressing, the amplitude will be more. That huge amplitude I'm going to call it as direct delta or an impulse. I'm going to call. So delta of t, which is equals to infinite at t equals to 0. At t equals to like non-zero, the value is 0 only. So this is how I am going to define continuous impulse or direct delta. Now next is how to talk about one property, that is scaling property in the case of delta function. So if I am talking about scaling property, this is important. If I am talking about scaling property is defined as what? It is delta of alpha times of t, which is equals to 1 divided by mod of alpha into delta of t. So this is one function. This is one thing what you have to remember. Next is, let us talk about triangular function. Why you require triangular function? Because already these questions they have asked. All these things they have asked in UGC NET. How are you going to define a triangular function? You are going to define a triangular function having a width of 2. Here area will be equals to 1 only. If area equals to 1, you just make use of this formula, half into base into height, as well as this is for half a triangle. For this half a triangle it will be 2. So what you are getting, width is equals to 2. Then what should be the height? You just calculate over. So this is how the function they are going to define. And this is triangular function. In the case of triangular function, they are going to represent as tri of t. Width is 2, area is 1. These things you have to remember while sketching the plot. Next, let us.
Area of impulse is also 1.
Area of impulse is also 1. Okay, let me write. If I am talking about area of the impulse, it is 1. Okay, I was about to explain in the next slide. Okay, area of the impulse is 1. Now if I am talking about Signum function, how Signum function you are going to define? Signum function is defined as like this, nothing but at t greater than 0, you will be getting a value of plus 1. T less than 0, the value will be minus 1. At t equals to 0, you are going to take an average. Again, you are going to take an average. It is 0. But how you are going to define practically? Practically, sudden change, anything is in sudden change, it is against the nature. So it will be something like this. But for mathematical purpose, how you are going to take? You are going to take which is like this. Now, define mathematically. So Signum function is defined as Signum, right? SGN. So Signum function with respect to time domain, if I am writing, it is of t. Signum of t is defined as 1 for t greater than 0, right? For if it it is minus 1 for t less than 0, and at 0 the value will be average. Again, 1 minus 1 divided by 2, it is 0 only. So this is how Signum function is defined. Now you please express in terms of u of t. Split the signal. If I am having a signal which is like this, can't I write it as u of t? Yes. And if the signal is like this, can I write it as u of minus t? With minus. Say suppose if I am writing just u of minus t, the signal will be like this. If I am writing this minus u of minus t, I will be getting in the opposite, like in the third quadrant I will be getting. So this is how Signum function is defined. Now expressing Signum function in the case of or in terms of u of t. If I am expressing the Signum function in terms of u of t, it is u of t minus u of minus t. Unit step I am expressing the Signum function. This is one method. One more method is like 2 times of u of t minus 1. So this is how it is defined. Anyway, u of t is not defined for t less than 0. Minus 1 will be this one. And in the case of t greater than 0, 2 times of u of t what? It is having an amplitude of 2. Minus 1 if you are subtracting, you will be getting an amplitude of 1. So this is how Signum function is defined. Right? At t equals to 0, again I am telling its value equals to 0 only. And at t equals to 0, what is 2 times of u of t? It is 2 times of half. Because at t equals to 0, what is u of t? Step function. It is half. So it is 2 times of 1 by 2 minus 1. It is 0. So this is how Signum function is defined. In detail, I have explained the video that I will be dropping a link in the description. You please go through it. Now, given a question, you should draw like a time domain curve. Say suppose if I am writing u of t plus 1 minus u of t minus 2 plus 3 times of u of t. So this is the function I want. What do you mean by t plus 1? Here I am performing shifting towards left side. Here it is t plus 1 means you are shifting on the left side. It is t minus of minus 1. The actual value is t minus t naught. If t naught equals to a negative value, you are going to shift on the left side. So all this thing is not important. What you remember is, if say suppose if I am writing it as plus, you are shifting on the left side. If I am writing it as minus, it is shifting towards right side. Only these things you remember. Now what do you mean by u of t? U of t is the one which will be having a signal from t greater than 0. So this is u of t. What is the amplitude of u of t? It will be having a finite amplitude of 1. Now you try to sketch what is u of t plus 1. So u of t plus 1 you will be getting from minus 1. U of t plus 1 you will be getting from minus 1 to infinite. So this is u of t plus 1. Now you try to sketch for u of t minus 2. So u of t minus 2 means what? You have to start from plus 2. Since I have given it as minus u of t minus 2, the curve should be reverse. So it will be like this. from plus to you should have a curve or you should have an waveform. So this is u of t minus 2 with minus u of t minus 2. Next, what do you mean by 3 times of u of t? 3 times of u of t means what? From t greater than 0, what you should have an amplitude? You should have an amplitude of plus 3. You should have an amplitude of plus 3. Now you try to sketch the overall value. You try to sketch the overall value. How you are going to sketch? Please look over. Now my signal is getting at minus 1. So you start from minus 1 only. Rest all the values, what is the thing? It is 0. So from minus 1 you start. From minus 1 you try to plot the values. So from minus 1 you are getting only one value. So it is u of t plus 1. So it is at 1. So the amplitude is at plus 1. So the amplitude is at plus 1. So you try to sketch. So the amplitude is at plus 1. Now at t equals to 0, one amplitude is at 3 and another amplitude is at 1, nothing but plus 1 you have to do. So this amplitude is at 4. This amplitude should be at 4. So this amplitude is at 4. Another 3 increment you are going to do. Another 3 increment you are going to do. So the curve will be something like this. The curve will be something like this. Now next change is occurring at where? At 2. Next change is occurring at plus 2. Now what is the value? From greater than 2, here you are having 1. Here you are having minus 2. But here you are having plus 3. What is 4 minus 2? It is 2 only. What is 4 minus 2? It is 2 only. What is 4 minus 2? It is 2 only. So this is how it is defined.
Second waveform, sir.
Pardon?
Second waveform, the amplitude is minus 2 or minus 1, sir?
Okay, I'm sorry. Okay, thanks for correcting. So it is minus 1. So minus 1 means what is 4 minus 1? It should be 3. 4 minus 1 should be equals to 3. So the value is at 3. Rest all the things from t greater than 2. From t greater than 2, what is the value you are getting? 3 minus 1 and plus 1. What is 3 minus 1 plus 1? It is 3 only. So from t greater than 2, it is 3 only. So this is how it is defined. This is how you are going to define. Any sort of waveforms you try to replicate. And one more thing is you have to talk about Laplace transform. So what is the Laplace transform of u of t? It is 1 by s. U of t plus 1 you are going to express in terms of exponent and then you are going to write. Say you given any problem, you go with the time domain analysis or you go with the frequency domain analysis, answer will be the same. So this is one example I have taken. Now let me talk about transformation of a signal. So what and all the operations you have to perform, let us study. So in the case of transformation of a signal, first property is you're going to perform time scaling. Nothing but what exactly you're going to do is you're going to either compress or you're going to expand. How you're going to define? Say suppose if my signal is x of t. In the case of time scaling, what you're going to do is you're going to write it as x of at. Say suppose if a is greater than 1, you're going for compression. This one thing you remember. If a is less than 1, you're going for expansion or expanding the signal. Right? Expand. And this is first property. And this is with respect to time domain. In the case of discrete domain, if I am taking, it is defined as x of mn. Nothing but in the case of compression, you are going to perform decimation. In the case of expansion, you are going for interpolation. Again, interpolation means what? You are going to add the bits. You are going to pad the bits, and that padding can be the previous value or equals to 0, or you want to take an average. So let us talk about it later. Now next one is we have to talk about time shifting. See, in the case of time shifting means what? You are going to shift the signal towards left or you are going to shift the signal towards right. So how you are going to define the case of time domain? it is defined as x minus r plus times of t naught. X minus r plus times of t naught. Or in the case of discrete domain, if I am taking, it is x minus r plus times of n naught. This is how you are going to define. This is how you are going to define the time shifting. Now, in the case of time reversal, if I am speaking, in the case of time reversal, if I am speaking, it is the signal is x of t. Now the signal will be x of minus t. Nothing but if it is on the positive axis, you are going to shift towards negative axis. If it is on the negative axis, you will shift towards the positive axis. This is what you mean by time reversal. In the case of discrete domain, it is defined as x of minus n. So this is how time reversal is defined. Our next property is amplitude scaling. Amplitude scaling means what? Either you increase the amplitude or decrease the amplitude. So it is k times of x of t, or in the case of discrete domain, it is k times of x of n. In the case of discrete domain, it is k times of x of n. K times of x of n. So these are all four properties you have to remember. The first one is a time scaling, time shifting, time reversal, and amplitude scaling. So they have asked the questions based on these properties. Now let me consider one signal or one waveform. Let us consider. So what is this? They have given from -1 to 0. They have given it as a ramp, followed by you will be having a value which is like this. So this is from 2 to 5. So this is from 2 to 5, right? So they have given like this. And let me consider this amplitude equals to 1, and you consider this amplitude equals to 2. You consider this amplitude equals to 2. And let me consider the signal is x of t. When the signal is x of t, you try to write in terms of mathematical expression. You try to express in terms of mathematical expression. Now what do you mean by step? It is like incremental fashion. In the case of ramp means what? It should be like this. It should be like this. Now one more signal we are going to define, that is ramp. So let me define ramp function also. So ramp function, how we are going to define? From t greater than 0, the value is, let me consider r of t. Let me consider r of t. R of t equals to t for t greater than 0. Again 0 for t less than 0. At t equals to 0, not defined. At t equals to 0, not defined. T equals to 0, not defined. Instant change, anything which is instant change, no, it is not possible, right? But most of the textbooks, what they will be telling is at t equals to 0, the value is 0 only, right? The value is 0. This is how they are going to define. And in this case also, if you are getting into some local authors, no, u of t equals to 0 for t less than 0, for t greater than or equals to 0, they are going to write it as 1. No, you have to take an average. So it is u of t equals to half for t equals to 0. This is one thing what you have to remember. Now we shall write the mathematical expression for this. Say if you are having a ramp, talk about y-axis. It is changing from 0 to 1. If it is changing from 0 to 1, what is y amplitude? Y amplitude equals to 1. Y amplitude equals to 1. What is the x variation in terms of time domain? In the case of time, it is also 1. So what is the slope? Or one more way to get the slope is, on the y-axis you take it as 1 minus 0, and on the x-axis it is 0 minus of minus 1. So the slope is 1. So you can write it as r of t. Is the signal starting from 0? No, the signal is not starting from 0. So it is starting from minus 1. Minus 1 in the sense what? It has been shifted towards where? Shifted towards left. So you're going to write it as r of t plus 1 with slope of 1. So this 1 is slope. How are you going to find the slope? y2 minus y1 divided by x2 minus x1. So this is how you are going to define a slope. Next, At t equals to 0, anyway this signal was supposed to extend. This signal was supposed to extend, but what we have made, we have cut down the ramp. We have cut down the ramp with the same slope. We have cut down the ramp with the same slope. So I have to write it as minus r of t. So instead of getting a ramp, now my signal is like this. My signal is flowing like this. Nothing but it is taking this path. Next thing is what you have to do is we have to talk about, now you have defined till here. Now at t equals to 2, one more change I am having. What is that one more change? The signal will be changing, the signal is changing from 1 to 2 and the signal nature is a step nature. So it is plus u of t. But where exactly you are getting a change? At 2 you are getting a change. So it is minus 2. What is the amplitude? It is 1 only. So increment change of 1. So the signal is here. Next change where you are getting? Next change you are getting at 5. Next change you are getting at 5. So what you have to do? Minus 5 times of 2 times of u of t minus 5 minus u of 2 times of u of t minus 5. Nothing but plus 2 was there, you are going to cut it out. You are going to cut it out by at same factor, that is 2. So it is minus 2 times of u of t minus 5. This is how I am going to define x of t in time domain. This is how I am going to define x of t in the case of time domain. What do you mean by u of t in the case of Laplace transform? It is 1 divided by s, and e power minus 5 s you are going to write as it is. What is r of t? It is 1 divided by s square. R of t plus 1, it is 1 divided by s square into exponent term you are going to write. All those things let us talk about later. But given x of t signal, you should know how you are going to express in terms of mathematical equation. This is important. Unable to understand? Let us solve the second problem. Let us take the second problem. So in the second problem what they have given is, the signal will be having a ramp kind of thing like this. So the signal value is 1.5 and 2.5. And let me call the signal as x of t, or you can call it even as y of t also. Now they are asking what is the mathematical equation for y of t. What is the mathematical equation for y of t? Is the signal starting from 0? No, the signal is not starting from 0. The signal is starting from 1.5. So it is t minus 1.5. Nothing but it is shifting towards right. So it is t minus, right? What is shifting from 1.5? What is supposed to start? A step it should start. What is the amplitude they have given? Let me consider 1.5, and this side, this one also for simplicity, let me consider 2.5. Let me consider 2.5. So how much increment you should have? 1.5 increment you should have. What you should have? A unit step. So it is plus 1.5 times of u of t minus 5. So where you got here. And if you would have not have ramped, you would have continued like this. But for this unit step, you are adding a ramp. Whenever you are adding a ramp, so it will take a ramp nature. So what is that you are having? You are adding a ramp, that is r of t. From where you are adding? From 1.5 you are adding. So it is minus 1.5. Why it is minus 1.5? It is shifted from origin to 1.5 distance towards right. So it is minus 1.5. What is the slope? It is 2.5 minus 1.5, that is 1, divided by 2.5 minus 1.5. It is 1. So slope is 1. So the slope is 1. Next, the signal is continuing. Now what you have to do is, you have to cancel that ramp. How you are going to cancel that ramp? By subtracting the same factor, that is minus r of t minus, from where you are cancelling? It is t minus 2.5. Now after cancelling the ramp, you are getting a signal which is like this. But even this unit step also you should cancel. What is the strength of this unit step signal? That is 2.5 times of u of t. But it is starting from 2.5. So it is minus 2.5 times of, that is amplitude, u of t minus 2.5. T minus 2.5 means what? A shifted version on the right side. So this is how you are going to define y of t. right? So I've explained two signals where I've taken x of t, which is this one, and the second one is y of t I've considered, right? So this is how you are going to define in terms of mathematical expression. Now what do you mean by 1.5 times of u of t? What is Laplace transform? It is 1 divided by s. Shifted version e power. R means what? A ramp. What is Laplace transform? It is 1 divided by s square. Shifted version e power. So this is how you are going to express in terms of time domain or frequency domain. So you can express this mathematical expression either in time domain or in case of Laplace domain, nothing but discrete domain also you can express. Now if I am talking about, see, Laplace transform means you have to talk about S domain. In the case of S plane you are going to take, right? So it is not correct if I am telling it as discrete domain. I can take it as S plane. S plane I can take, right? Now next thing is we have to talk about, if say suppose if I am compressing in time domain, what is the thing that is going to happen in the case of frequency domain? You are going to perform expansion, nothing but in the case of
excuse me, sir. Sir, in previous question, last term why it was not 3.5 minus 3.5 because plus 1 slope
see, you are having a
last term.
you are having a curve which was like this. So
Yes,
if
sir.
this line was not there means you would have a curve which is something like this. What you are going to do is first chop out that ramp. First you try to chop out that ramp. When you chop the ramp, your signal will be like this. Next what you have to do is you have to cut
Yes,
down
sir.
this unit step. So what I have done is at 2.5 I am performing two operations. The first one is I am cancelling the ramp. And in
Yes.
the next case I am just cutting down the step also. At 2.5 I am performing two operations. Still doubts?
Okay, sir.
Okay.
Yes, sir.
Now in the case of compression, if you are doing in time domain, it is a decimation in the case of discrete domain. Similarly, if I am talking about expansion in time domain, it is same as interpolation in other domain, that is interpolation in discrete domain. So this one thing you just remember, actually it is not important. If I am talking about these things, interpolation and decimation, no, interpolation and decimation is important, but compression expansion you just neglect. Now one question I have asked, see, the opposite of interpolation is decimation, the opposite of decimation is interpolation. So most of them told both the things are correct, assertion is correct, reason is correct, but it is not giving the proper explanation. Now let us talk about interpolation. Now in the case of interpolation means what? You are going to pad either 0 or what you are going to pad, let us discuss. So in the case of types of interpolation, we are having four types. The first one is zero interpolation and the second one is step interpolation. Only these two things are sufficient if you are preparing for any of the exams. And next interpolation is linear interpolation. For your understanding purpose or to gain knowledge, one more interpolation is there, spline interpolation. What do you mean by spline interpolation? Let us not bother. What do you mean by interpolation? Let us talk about. So in the case of zero interpolation, what you are going to do is you are going to pad zeros. In the case of step interpolation, what you are going to do is you are going to retain the previous value. In the case of linear interpolation, what you are going to do is you are going to take an average and then you are going to solve the problem. Consider an example and try to get what is the expansion or what is the value you will be getting for zero interpolation, what is the sequence you will be getting for step interpolation, all those things let us derive now. Now if I am talking about the sequence x of n, which is equal to, you can consider any sequence of your choice. Let me consider 1001 and they have given the interpolated value as let me consider L equals to 2. Now what do you mean by L equals to 2? Nothing but you have to pad 2 minus 1 values. You have to pad 2 minus 1 values. 2 minus 1 values means what? In the case of zero interpolation, 1, 0, 0, 1 is my input. You have to pad 2 minus 1 zeros.
Sir, voice is very much distorted.
Same amount of distortion or it is
No,
no distortion?
No distortion, sir.
Okay. See, in the case of x of n, I have considered this sequence 1 0 0 1. In the case of zero interpolation, what you are going to do is you are going to pad zeros. How many zeros you are going to pad? 2 minus 1, that is L minus 1. Interpolation value they have given it as 2, 2 minus 1 zeros you have to pad. So this is your sequence. This is interpolated sequence. In the case of step interpolation, what you are going to do is you are going to retain the previous value. Say suppose if this is the sequence, you are going to retain the previous value. This is in the case of step interpolation. In the case of linear interpolation, you are going to take an average. So this value is 1 0 then 0 1, right? What is the average value between 0 and 1? It is 0.5. So take it as 0.5. 0 to 0, what is the average? It is 0 only. 0 to 1, what is the average? It is 0.5. Right? Now this is your interpolated sequence. Now I have explained with respect to zero interpolation and step interpolation. These two things are important, and even for gate also, no, zero interpolation, step interpolation and linear interpolation is only important. Let me not talk about spline interpolation, that is out of box, right? So what you have done is you have interpolated, nothing but you have increased the sequence or you have increased the length. This is with respect to interpolation. Now if I am decimating by the same factor, that is like if I am decimating by m equals to 2, nothing but 2 minus 1 samples I have to delete. If I am deleting all the samples, 0, 1, 0.5 it is going to delete. And here also it is 0, 0, 0 you are going to delete. You are going to delete 0, 0, 0.5 in each and every case. But if I am talking about decimation, let me consider the sequence as 0, 0, 1, 2, 4, 5. 0, 0, 1, 2, 4, 5. It's the sequence they have given. Say suppose if I want to remove one bit, nothing but they have given m equals to 2. Now what you are going to do? You are going to remove one bit. So 0 becomes 1, 1 becomes 4, 4 becomes, next is 5. So this is how you are going to perform decimation. So from interpolation to decimation, this is how you are going to do. You are going to do. Say suppose if I want to retrieve the signal, decimation to interpolation I have to do. Next step is like from interpolation to decimation I have done in order to reduce the bit. At the output end I have to interpolate, nothing but I have to expand the signal. So what you are going to do? You are going to write the sequence 0, 1, next value is 4, next value is 5. So the same thing you write 0, 1, 4 and 5. In the case of zero interpolation, what you are going to do? You just tell me. You are going to pad zeros. Right? So actually you are going to pad zeros. But in the case of step, you are going to retain the previous value. But in the case of linear interpolation, you please check over. 0 will be retained as it is, 1 will be retained as it is, 4 will be retained as it is, 5 will be retained as it is. Now what is in the middle? 0 to 1 average is 0.5. 1 to 4 average is what? 1 to 4 if I am taking, like it is 2.5. 4 to 5 average is what? 4.5. Now you try to compare this sequence with the obtained sequence, what you will be getting? The opposite of decimation if I am doing, you are not getting actually the interpolation, because what type of interpolation you want, you don't know. Again the system is in confusion. So what you have to do is, if you are going for interpolation to decimation, it's well and good, there is no problem. But if you are thinking about decimation to interpolation, you please check over the accuracy of your inputs. You have to check over the accuracy of inputs. So interpolation to decimation you can do, but the opposite of decimation is not interpolation, because try to match with the sequence. Whether you are getting the same number, no, you are not getting the same sequence. So whenever you are not getting the same sequence, the opposite of decimation is not interpolation. What many textbooks says is the opposite of decimation is interpolation. This is again a myth. One more myth you have to know. Again I am going to repeat, the opposite of or the reverse operation of interpolation is decimation. True. The reverse operation of decimation is not interpolation. It's not interpolation. This is one thing what you have to remember. Now if I am talking about the classification of signal. Now if I am talking about classification of signals. If I am talking about classification of signal. How you can classify, this is important. You can classify as energy signal as well as power signal. Energy signal as well as power signal. The second classification is you can classify as even signal and odd signal. The third classification is periodic signal and non-periodic signal or aperiodic signal, right? And the fourth classification is causal and non-causal signal. What do you mean by causal? What do you mean by periodic? I am going to discuss causal and non-causal signal. The fifth classification is deterministic signal. Deterministic means you can able to predict the nature of the signal. And the next one is random signal. Random signal, it is the nature is very much difficult to predict. So this is the classification of signals. If you are preparing for any sort of exams, this classification you should know. What do you mean by energy signal and power signal? The first classification is we should know what is the difference between energy signal and power signal. See, in the case of energy signal, you will be having a finite amplitude. You will be having a finite amplitude, right? This is energy signal, and at t equals to plus or minus infinity, at t equals to plus or minus infinity, the signal value will be equals to 0. The signal value will be equal to 0. Say suppose, let me consider this example. This example is a energy signal. At t equals to infinite, its value is 0. This is an example for energy signal. Nothing but at t equals to plus or minus infinity, signal value should be equals to 0. Now, what do you mean by power signal? Same. It should have a finite amplitude. It should have a finite amplitude at t equals to plus or minus infinity. At t equals to plus or minus infinity, the signal should be defined. Example is take u of t. Example is u of t. At t equals to plus infinity, the signal is defined. If I am talking about minus u of minus t or u of minus t, the signal is defined at minus infinity. So this is the difference between energy signal and power signal. What sort of questions they will be asking? Energy signal will be having a finite power. See, energy signal will be having a finite power, they are asking. So if they are asking it is having the finite power, you should tell it as yes, because the signal is defined only for an interval. It is defined only for an interval. So it is having finite power. Now if I am talking about power signal, it will be having infinite energy, because the signal is defined either from 0 to plus infinity, or it is defined at even minus infinity also. So this kind of signal is a power signal. Example, let me talk about noise. Example, let me talk about noise. How you are going to draw a spectrum? It will be having a amplitude of n0 by 2, white noise, right? So at t equals to plus or minus infinity, in both the cases it is defined. So it is a power signal. So it is a power signal. One question I have asked, can a signal be both energy signal and power signal? No, it can't be, because if it is having finite amplitude at some intervals, then it will be falling under energy signal. At t equals to plus or minus infinity, if the amplitude is constant, then it is a power signal. So the function or the signal can be any signal. If you are considering, it can't be both energy signal as well as power signal. So either it will be energy signal or it will be power signal. One more question they will be asking, can the signal be neither energy signal nor power signal? Yes, it can be. How? Let us discuss. Now you please consider this example. At t equals to infinity, what is the value you are getting? At t equals to plus or minus infinity, what is the signal you are getting, or what is the amplitude you are getting? Amplitude equals to infinite. So it is not a power signal, and it is not even an energy signal. One more example they are going to give is this one. One more example they are going to give is this one. At t equals to plus or minus at t equals to 0, the signal is not defined. At t equals to 0, the signal is not defined. So signal is not defined means what? It is neither energy signal nor power signal. At t equals to plus or minus infinity, if the amplitude is also tending to infinity, it is not a power signal. It is not a power signal. So this basic difference you should know. Next, if I am talking about even signal as well as odd signal. Next, if I am talking about even signal as well as odd signal. Now, what do you mean by even signal?
Periodic signal or even or odd.
Okay. Say suppose if I am taking x of t, if I am taking x of minus t, if this both the things are getting the same, then you can take it as an even signal. Or this side, what is the nature you are getting? If it is getting matched with this side, then you can tell it is directly an even signal. It is an even signal. This replica you should get. Now, if I am talking about odd signal, where should be the replica? The first quadrant, it should be replicated in the form of, or it should be replica of the third quadrant. If I am talking about a Signum function, how they are going to define? It is like this. At t greater than 0, the value is 1. At t less than 0, the value is minus 1. Now, what is the question they have asked? Area property. Area of an odd signal. So, area of odd signal you take, it will be equals to 0. Because how much area it has covered in first quadrant, the same area it will be covering in the third quadrant also. So area of odd signal equals to 0. You just go through previous year question paper, this only they have asked. So they will be telling like basics is not important, but all the questions you see they are asking from basics only. So this is about even signal and odd signal. Next they will be talking about periodic signal, and we have to talk about non-periodic signal. And non-periodic signal. Again, here they are going to trap. How? Let us discuss. Now, if I am talking about periodic signal, so this is time period t means it should be replicated throughout. At t equals to infinite also it should be there. At t equals to plus or minus infinite, the signal should be there. The signal should be available. At that time you can tell it is a periodic signal. If it is not getting, then it is a non-periodic. So you define for a time period. You take one time period. Whether it is getting replicated, then it is a periodic signal. Now let me give one more example. So this one is actually a favorite question for them. So they are going to give like this, and they are going to give like this. Now you talk about periodic. Now you talk about the periodicity. So if I am talking about from year to year, from 0 to infinite, the periodicity is maintained because the time period you want to take, it is like this. But on the negative side, if I am taking some signal, it is getting replicated. Now you please talk about at t equals to 0. What is the thing that is going to happen? There you are getting a discontinuity. So whenever you are getting a discontinuity kind of thing, is the signal periodic? No, not a periodic. The signal is not a periodic. One more signal they will be giving, one more example. At t equals to 0, it starts, the signal starts. So at t equals to negative values, the value is 0 only. This is periodic, they will tell. No, it is not periodic. Actually, it should be non-periodic only. So one more name what they are going to give is switch periodic. Switched periodic. Switched periodic means what? It is starting from one particular value and it is continuing throughout. So this is what you mean by switched periodic signal. So this one thing you have to remember. Can anyone define what is the signal value? Say suppose if x of t equals to what? x of t equals to u of t into sine of omega t. Sine of omega t. So this is how we are going to define. What is omega? Like you're going to define in terms of like radians per second. It is 2 pi f, or it is 2 pi divided by capital T. So based on this only they are asking the question. Given any problem, they will be telling, right, is this a periodic signal? So they have given some cos of the 3t plus cos of 12t, then they are going to ask whether it is a periodic signal or not. You just go through previous year question, but they have asked one question on periodic, right? Simple basic questions only they will be asking with respect to periodic and non-periodic. Now if I am talking about one more example, they will be talking about, is the signal periodic or not. So they are given one example, cos 3t plus cos 12t, cos 3t plus cos 12t, right? At the time you are going to go for either GCD method or LCM method. So based on that we are going to solve whether, based on that we are going to derive whether it is periodic or non-periodic. But as of now, let us not bother. Or if at all if you want to express, you can express like this. You can express it as cos of omega 1t, cos of omega 2t. So what you got omega you got 3. What you got omega 2, which is equals to 12, Now you take GCD of omega 1 and omega 2. So what you will be getting? 3. Now what do you mean by omega? It is 2 pi f. Can I write it as 2 pi divided by capital T? Yes, I can write. So which is given as t equals to 2 pi divided by, what is the value of omega you got? It is 3. So based on this you are going to derive whether it is whether the signal is periodic or not. Whether the signal is periodic or not, you are going to define. And most of the cases they are going to define in terms of cos 3 pi and cos pi 12 pi, like that they are going to define. And say suppose if you are having a function, say cos 3t plus one more function, if they are given it as cos pi t, wherever you are having pi, no, directly you can tell it is not a periodic signal. Wherever you are having a pi, it is not a periodic signal. Pi means what? It is not 3.1415, it is exactly 22 by 7 you want to take. And whenever you are having a pi, how you have derived the value of pi? Again you have made an approximation. So whenever you are having a pi, directly straight away you can tell it is a non-periodic signal. You are having in two places you are having a pi, then you should consider a periodic signal. Periodic signals means what? It will be having a continuous value. And one favorite question they will be asking, convolution of periodic signals, convolution of two periodic signals, convolution of periodic with non-periodic signal, convolution of non-periodic with non-periodic signal. So these kind of questions they will be asking. I have already shared the material to you, so in that one I have explained each and everything. If not, you just go through my previous video. In that one I have explained how you are going to take. I have taken some 2-3 examples and I have explained how to check periodicity with the help of GCD method as well as LCM method. And next one, it is causal and non-causal. What do you mean by causal and non-causal? So if I am talking about causality and non-causality, so all real signals are causal in nature. Nothing but my signal should be t greater than 0. After t greater than 0 only my signal should lie. So it is causal signal. So can I tell causal signals are real signals? Say suppose I am using cell phone. I just took the cell phone, that is at t equals to 0. Whatever the operations I am performing, it is t greater than 0 only. So it is causal signal. Causal signals are what? Real signals. Now if I am talking about anti-causal signal. Now what do you mean by anti-causal signal? The signals where you are going to define when negative. Nothing but at t equals to 0. Imaginary thing. Nothing but you are going to rewind and you are going to play. That is a pre-recorded one. If you are rewinding and if you are playing, then it is an anti-causal signal, which is not a real one. Next, we have to talk about non-causal. So non-causal means what? Negative as well as positive, right? So this is if the signal behavior is with respect to on the negative axis as well as positive axis, then it is considered as a non-causal signal. So these things you have to remember. So based on these things only they have asked the question. What is the question they have asked? What is the question they have asked? See, if I am considering one point over here, if I am moving towards right, I am going to call it as right-sided signal. I am going to call it as right-sided signal, right? And if moving from this point, if I am moving towards left, then it is called as left-sided signal. This is one thing you have to remember. This is one thing you remember. Now, if I am talking about causal signal, causal signal means what? From t equals to 0, if I am speaking, it should be towards right. All causal signals are right-sided signals. All causal signals are right-sided signals if they are telling. Put it a tick mark. Yes, it is a right-sided signal. They have given statement 2. All right-sided signals are causal. All right-sided signals are causal. They are telling all. All means what? In each and every condition it should satisfy. In each and every condition it should satisfy. So you put it as a wrong. Why it is wrong? Let me explain now. Say suppose if the signal is starting from here 0, it is a right-sided. Yes, it is a causal. If the signal is starting from here, yes, it is a right-sided. It is a causal. Say suppose if the signal is starting from here, it is a right-sided. Yes, is it a causal? No, it is a non-causal signal. So these things you have to remember. All causal signals are right-sided signal. Yes, it is a right-sided signal. All right-sided signals, is it a causal signal? No, definitely it can't be, because they have given it as all. There may be a possibility means yes, there may be a possibility, but here they have defined it as what? They have defined it as all. So all right-sided signals are causal will be a wrong statement. So this is one thing what you have to remember, right? Next, let us talk about the type of a system. And one more property is there, I forgot to tell. Deterministic signal as well as random signal. Deterministic signal as well as random signal. Now what do you mean by this deterministic signal? Let me talk about this signal behavior. Like it is something like this. What is next value? It is like this. What is next value? It is like this. Nothing but prediction is possible. You can predict. So wherever you can predict, that signal is called as a deterministic signal. What is 2 minus 2? It is definitely 0. That is deterministic signal. Say in this case a random signal. So in this case if it is random signal, what is next? What will be the next value? No, you can't find. Again it is a probability. What is the next value you are going to take? It is a probability. So all the non-linear systems you are going to operate based on probability only. With the help of trial and errors only you are going to operate. All the robotics like which is operating in like real world, all the real environment, it is like random signals. With the help of random signals only you are going to operate, right? So in the case of like digital communication, the first topic should be random process and random variable, but gate they have followed, but in the case of UGC and ET they have not followed. So random means anything you take in this world, it is random only. Tomorrow what will happen we don't know, so it is random. Anything is going to happen, it is random, right? Next, let us talk about type of a system. So if I am talking about type of a system, till now we have discussed with respect to signal. We have discussed with respect to signals. Now we are going to talk about type of a system. Now in the case of type of a system, we will be having a linear system and non-linear system. If the system is a linear system, which approach you are going to make? Signal flow graph. Non-linear system, block diagram, right? This is how you can relate control systems with signals and all sort of things. And entire signals, if I am speaking, you are going to make use of control systems. And control systems you are using, you are going to make use of network analysis. Communication you are going to make use of again the components, which is network analysis. So, and network analysis if you are using in the digital, you are going to relate with respect to digital electronics. So each and every subject is interrelated. An engineer is the one who is going to study each and every subject, and degree students also they will be studying each and every subject. But interlink, if they are failing, then we will be thinking that all the subjects are of no use. So if I'm talking about types of a system, I can classify into linear and non-linear system. The second classification is time invariant. The second classification is time invariant and time variant. Time invariant as well as time variant. The third classification is causal. The third classification is causal and non-causal. Causal and non-causal. System to signal, you please don't merge. Next, let us talk about static and dynamic. Static is something like you have to relate with respect to combinational circuits, no memory. But dynamic means it will be having a memory, sequential circuits. The next one is stable system and unstable system. Stable system and unstable system. So this is the overall classification of a system. And one more thing is there, that is invertible and non-invertible. Invertible and non-invertible. So these are all the classification of a system. These are all the classification of a system. Now what do you mean by linear? Now what do you mean by linearity? So a linear is the one which is going to obey homogeneous property, means like what? Additive and as well as scaling, that is homogeneity. But if I am talking about linear system, you try to plot a graph. If your plot is something like this, if it is passing from origin or if it is passing through origin, then it is a linear. Then it is a linear system. One question they have given, is this system is a linear? It is actually like a shifted linear, shifted curve. You can tell it is a non-linear system. The curve what you are getting or the response what you are getting is a non-linear one, because it is not passing through origin. So this is the basic difference between linear system and a non-linear system. Non-linear system example is simple. You take a diode or you take a Zener diode, right? So this is an example for non-linear system. Now if I am talking about time variant and time invariant, if I am talking about time variant and time invariant, with respect to time, if I am speaking, if it is varying, then it is time variant. With respect to time, if it is not behaving, then it is time invariant. Let me consider one example. Y of t, which is equals to t times of cos t. Now you take input. In the first case, what you take is y of t. How you are going to define is, you take t as wherever you are having t, you replace with the t naught. Wherever you are having t, you replace with the t naught. So this is first equation. Next, the second equation is wherever you are having that input term, say suppose it is x of t. So only at the input term you want to vary. If you are to vary, rest all the parameters you don't touch. If these two things are same, if these two terms are same, then it is time invariant. Is it same? No, it is not same. So the system what they have given is a time variant. Again I am going to repeat. In the first case, wherever input you are having, only that one you want to change. In the second case, wherever you are having the t, that is a dependent parameter, wherever you are having, just replicate over there. At that time you will be getting one more expression. Is these two expressions are same? If these two expressions are same, then it is a time invariant system. If not, it is a time variant system, right? So this is how you are going to define time variant as well as time invariant. Now let us talk about causal system. Let us talk about causal and non-causal system. Let us talk about causality as well as non-causality. Now in the case of causal signal, what I defined is all the real terms are causal. But in the case of system, if I am speaking, means anything which can able to process with the previous data as well as the present data, then that system is called as the causal system. Nothing but previous data it is taking, as well as present data it is taking. So processing will be only this data, this one only, right? What is the future data? We don't know. Can we process on the future data? No. Future data you can't predict. So if that's the case, then it is a causal system. A causal system. Just for understanding purpose, we have derived even non-causal system also. Non-causal system, how you can define, say, like tomorrow what is the input I am getting? Predict now only and you will solve. Is it possible? No. But for understanding purpose, we can do. Why we are going to make use of non-causal system means, say suppose if anything is going wrong in future, we have, at that time what should be the precautionary measures I have to take. At that time we are going to make use of non-causal systems and we are going to derive. So future prediction you are going to make. You are going to make use of a future prediction in the case of non-causal system. Wherever you are going to encounter future prediction, that system is called as a non-causal system, right? Next, static system as well as dynamic system. Static system is a one where y of t equals to some k times of x of t, where k is a gain factor. But in the case of dynamic system, it is not the scenario. It is not the scenario. If it is having a memory, in the case of dynamic system, if it is having a memory, then it is a dynamic memory system. If it is storing the previous value, then it is a dynamic memory system. If it is predicting or storing, then also the system is a dynamic system. Static means at that moment of time, what is the input you are giving? Process it. Example, combinational circuits. Dynamic systems are sequential circuits. How I related this digital electronics with signals is like this. This is all about static and dynamic. They can ask you, IR filter belongs to what? Static or dynamic? So let us discuss all those things. Now, last one is we need to talk about stable and unstable system. We have to talk about stable and unstable system. Now, what do you mean by stable system? If you are giving a bounded input, I should get a bounded output. What do you mean by bounded output? Finite input. In the case of LTI system, I consider the same scenario. In the case of LTI system, I consider the same expression, bounded input and bounded output. So this is how you are going to check for the stability. At t equals to plus or minus infinity, the signal should not be there. If at all, if it is there, it should be a finite value, right? So this is how you are going to define a stable system and an unstable system. What will be the procedure? What will be the graph of the, in the case of unstable system? It is like this, tending to infinite, or it is like this. All these things are unstable system. Diode curve, if you are taking, it is an unstable, but we are going to, it will be having the saturation within it. So if you are going to tell that diode will be a linear device, you are going to tell diode is a linear device. Say suppose if you are thinking so that as I am increasing the voltage beyond this value, say suppose if I am applying a voltage of 10 volts, I'll be getting a current which is of infinite. No, it is not the scenario. What you will be getting is just a spark from your device. The device is going to get burnt out. What you will be thinking is this curve will be tending to infinite and you will be getting some infinite current. That is not the scenario is going to happen. So what you are going to do is, after diode you are going to connect some other element. So in order to block that current, in order to reduce that current. So this is how diodes are used, and that is like this is how you are going to cut down that current. So even though I am telling all alone, if I am using the diode, diode is a unstable element. But for rectifying and all, I am going to make use of diodes. For rectification purpose, I am going to make use of diode. Only diode I am not going to connect. I am going to connect load resistor, all those things, elements will be there, such that I will be giving protection to the diode. Right? Next thing is, we have to talk about this. This one is important. What do you mean by invertible system and what do you mean by non-invertible system? What do you mean by invertible system and what do you mean by non-invertible system? In order to prove this, you consider like plus values as well as minus value. Say suppose if y of t equals to x square of t, y of t equals to x square of t, one function they have given. Say suppose if x of t equals to u of t, what you will be getting? 1 for t greater than 0 you will be getting. Say suppose if I am giving, say suppose if I am changing this x of t to minus u of t, minus u of t, what is the value I am getting? It is the same. It is the same. Am I having a unique set of inputs? No unique. No unique. So the system is non-invertible. So the system is non-invertible. Unable to follow? Let me give one more example. Let me give one more example. Y of t. Y of t. If I am taking y of t equals to x of t minus 5. X of t minus 5. Now what I am getting is, say suppose if I am taking as u of t, so it will be like u of t minus 5. And if I am changing the input u of t to minus u of t, what I am getting? I am getting it as minus u of t minus 5. I am getting minus u of t minus 5. Minus u of t minus 5. Say if I am changing the input on the input side, on the output side also it is changing. So, but here if I am changing the input, but on the output I am not getting the, I am getting the same value. So here it was plus, here also it is plus. But here it was plus, but here it is minus. So unique things are related. So whenever I am getting an unique one, then the system is an invertible. Then the system is an invertible. What is unique within you? You just focus on that one, right? So in this one, what I can tell is you just take a transfer function and you try to take the inverse transfer function. If it is equal to an identity matrix or if it is equal to an identity one, then only the system is an invertible. This is the condition for invertible. If it is identity or if it is like equal to 1, then only the system is an invertible system. So what and all the things I have discussed? I have discussed with respect to the signal. So I have talked about several signals, energy and power signal. Most of the assertion and reasoning will be based on this one only. I have talked about even and odd signal, periodic and aperiodic signal, and causal and non-causal signal, deterministic and random signal. Even I have talked about types of system, linear and non-linear system, time variant and time invariant, causal and non-causal, static and dynamic, stable and unstable system. Last, I have discussed with respect to invertible and non-invertible system. Now I am going to derive some rules or some direct expressions or direct laws I am going to derive. But before to that, if you are having any questions with the things what I explained just now, you please let me know.
Sir, inverting or non-inverting is not clear.
See, in the case of invertible and non-invertible, if you can able to generate one unique input, or like say suppose if you are giving an input, you are getting an output. If you are trying to give some other input, you will not be getting that particular output. So in order to achieve some desired task, you have to give that particular input only. If you can able to get that output in multiple ways, say suppose if you want 2 as the output, if you want 2 as the output, what I can do? 1 plus 1 is also 2, 1 plus 1 is also 2, 4 minus 2 is also 2, 4 minus 2 is also 2, root 2 times of root 2 is also 2. So this is nothing but like a non-invertible. So in order to get a particular output, I need to have an unique input, nothing but a particular input should have, and that system is called as an invertible system. Now where they are going to use, where they are not going to use, that is not important for us. How we are going to classify the system is important. Invertible means like unique you want. Non-invertible means, say suppose you want to generate a report. Say you are an engineer, you want to generate a report. What you can do is either you can prepare the report or you can just do a copycat kind of thing. So this is non-invertible, right? Able to understand like this.
Sir, minus u of t equal minus 1 na, for t greater than 0.
Minus u of t is for?
-1, na?
Okay.
For t greater than 0.
This one.
Yes, sir.
See, what is minus u of t the whole square or t greater than 0? Okay, you just don't bother about these things. You just don't bother about these things. What is x square of t means? Say suppose x of t, if you're taking it as minus u of t, what you're going to do is you're going to take a square of it. You're going to cancel this one. So it is something like u of t square only. So it is u of t square only. So mathematical is different, graphical is different. But if I'm taking it as minus u of t, it is 1 only, because I am going to define it as x square. If it is in terms of x square, so let me to be very much precise, it is x square. Okay, now it is okay.
Yes, sir, got it. Yeah.
Any other doubts?
Sir, in case of bounded input, bounded output stability, if we are applying sine or cos signal and we are using an integrator or differentiator system, so we'll get sine or cos output. In that case, will that system be stable?
Of course it is stable. It is stable.
So the
What do you mean by stability? At t equals to plus or minus infinity, the output value should be like a finite value. Output should be like a finite value. If it is finite value, then it is a stable system. That's it. Any more doubts? Now, few properties you have to know. The convolution of anti-causal. The convolution of anti-causal with the same will be an anti-causal signal only. The convolution of causal with causal is always a causal. If you are convoluting an anti-causal signal with causal, it can be causal or it can be non-causal. Only you try to remember these things. How we got is not important. So you try to remember only these things. And one more thing, what you have to remember is they have given this question. If you are convoluting or if your convolution of two equal rectangle signals, like width is equal in this case, width of rectangle signal, then you will be getting a triangular signal. Convolution of two unequal width of rectangular signals. What you will be getting is trapezium kind of thing. This question I have asked in my mock test. I have asked in a mock test. So how you will be getting is you will be getting like this. So this is one more thing what you have to remember. Now, few properties are there. Odd signal multiplied by odd signal will be an odd signal only. Odd signal multiplied by even signal will be again an odd signal only. Even signal multiplied by an even signal will be an even signal. Even into odd is odd only. This is one thing what you have to remember. Next thing, odd signal plus odd signal will be an odd signal only. Right? I'm sorry, I made one mistake. Odd signal into odd is even signal. Right? Next, odd signal plus even signal if I am making. Odd signal plus even signal if I am making, I can't tell. Whether it is odd or even, I can't tell. Most of the cases it will be neither odd nor even. Most of the cases it is neither. Neither odd nor even. If I am talking about even and even signal, even plus even signal will be always an even signal. So this is one thing what you have to remember. So this is all about the basics of signals and systems. Now I will be talking about FIR filter, IAR filter, type, Chebyshev filter, Butterworth filter, and what do you mean by fiddle factor, and one important question is there. Important question with respect to sampling frequency. That one I am going to solve. So what and all the things I have discussed with respect to causality and anti-causality, and few proofs I have given, and this one you have to remember. Now if I am talking about impulse invariant signal, impulse invariant response and finite impulse response, that is IIR filter. If I am talking about the difference between IIR filter and FIR filter, what is the difference you should know. And this one question I have framed based on this also. I have compared with respect to combinational circuits and sequential circuits with respect to Mealy and Murray model also. And one more thing they will be asking, final value theorem is applicable for where, and it is going to fail when the poles are on the imaginary axis, and initial value theorem where it is going to fail. All these things you have to remember. If I am talking about impulse invariant, it is used to provide magnitude approximation. It is used to provide magnitude approximation. Where you are going to make use of FIR filter. When you want linear phase response. Whenever you want a linear phase response, make use of FIR filter. Right? Stability is not guaranteed in the case of IIR filter. Stability is not guaranteed. But in the case of IIR filter, stability is guaranteed. Now, the third difference is IIR filter requires less order. What do you mean by order? That S power terms is there, no? That is order. But in the case of FIR filter, it requires more order. Simple example, if I want to give, in the case of IIR filter, you just try to solve 5th order or 6th order. In the case of FIR filter, it will be 12th order or 14th order. So this is one difference what you have to know. If it is less order, nothing but can I tell circuit is less complex? So complexity is less. Here complexity is more. Now one more thing what you have to tell is, if you are preparing only for gate, you just remember this one. In the case of IIR filter, you are in need of analog counterpart. What do you mean by analog counterpart? It is up to you. You just remember that in the case of IIR filter, you are in need of analog counterpart. That's it. And in the case of IIR filter, your output is a function of input as well as past output. But in the case of FIR filter, output is a function of input. So can I relate this IIR filter as a sequential circuit? And can I relate this FIR filter as combinational circuit? Yes. This is the basic classification between an IIR filter and FIR filter. In the previous year, what they have asked, IIR filter requires less order. At that time, if you are knowing the classification, it is very much easy. Again, I am going to repeat. In the case of IIR filter, it requires less order. Now, if I am talking about two filters, the best one is, you will be talking about Butterworth filter, and you will be talking about Chebyshev filter. So in order to explain this Butterworth filter and Chebyshev filter, let me consider a low pass filter. So in the case of low pass filter, you will be having a response which is something like this. Right? So at higher frequency components, the value will be equals to 0. Similarly, in the case of Butterworth filter, main thing is you will not be getting a ripples. So this is pass band, this is stop band. This is pass band and this is stop band. And here you are going to talk about the cutoff frequencies. Now if I am talking about Chebyshev filter, you will be having two circuits. You will be having two types. The first one is, it will be having like this. The second one is, which will be like this. So what do you mean by this ripple? Means on the pass band, if you are having a ripple, then it is called as type 1 Chebyshev filter. In this case, it is referred as type 2 Chebyshev filter. In this case, it is referred as a type 2 Chebyshev filter, right? And one question I have asked in this one, order required is less, but in the case of Butterworth filter, order required is more. Can I tell? Always there will be a trade-off between order and ripple. You want ripple, go for Chebyshev. You want order less, go for Chebyshev. But we don't want ripple, go for Butterworth. But if you are making use of Butterworth, order is more, right? So, any doubts till now? What and all the things I have discussed till now, if you are having any doubts, please let me know.
Sir, if we don't want the disturbing output from a filter, so ripple-less will be better. So in this case, Butterworth is better than Chebyshev.
But circuit complexity is more, right? Order is more. Order is more. Order is more. But here order is less. You have to, if you are very much compromised with respect to ripples, go for Chebyshev. If you are very much compromising with respect to circuit complexity, then go for Butterworth. Circuit complex is more. Able to follow till now? Guys?
Yes, sir.
Okay.
Yes, sir.
Okay then. Next, let us talk about this one table you remember, and this table is only for actually gate. This table it is exclusively for gate. Type, symmetry as well as length. Type, symmetry as well as length. Now what do you mean by type? Say suppose if the type is 1, if it is 2, if it is 3, if it is 4. If the symmetry is like even symmetry, again here it is even symmetry, here it is odd symmetry, here it is an odd symmetry. Sorry, and the length is an odd, and the length is here even, and here it is odd, and here also it is even. So in the first type, what you are going to do is you can able to realize only band stop filter. So in rest of the cases, a band stop filter you can't realize. So like based on this, in which cases you can realize band pass filter, all those things they will be asking. Only the thing is they will be relating with respect to type 1. Type 1, what is the symmetry, what is length? Type 2, what is the symmetry, what is length? Say suppose if they have given a sequence, say go for this sequence 1, 2, 3. And here also you go for the sequence 1, 2, 3. Now symmetry about origin, symmetry about 0. It is symmetric about 0. So it is symmetry. And it is an, how many samples are there? 1, 2, 3, 4, 5, 6, 7. So length is what? 7. 7 means what? Odd. It is symmetry. Symmetry with respect to what? It is something like an even symmetry kind of thing. It is even symmetry kind of thing. So it is type 1 system. It is type 1 system. All these things you please don't bother. Only the thing is, like if at all if you want to remember, if you are even preparing for gate now, you have to remember this one. They will be giving a sequence directly. They will be telling which is this sequence corresponds to which type, type 1, type 2, type 3, type 4 they will be asking. So at that time you should be in a position to answer. UGC NET board, they have not come up to this level. You don't worry. They will take another 2 or 3 years. Now one factor is that twiddle factor you have to talk about. That in the case of DIT, FFT and DIF, FFT, no, you have to talk about the twiddle factor. So it is defined as e power minus j 2 pi divided by n. This is twiddle factor. Why we are going for twiddle factor, or what is the necessary of twiddle factor? So we will be discussing later. Like if at all if you want to discuss that Butterworth, no, at that time you can discuss this one. And it is also referred as phase factor. It is also referred as phase factor. Now one thing what you have to remember is, if I am talking about DIT FFT, on the input side you are going for bit reversal, nothing but it will not be in order. The inputs are not in order. How you have to take? If it is suppose like 8-bit length 04261537, how we got, it is not the important thing. If you want further in detail, watch that video I have explained. In the case of output is like normal sequence. Normal sequence what? 0, 1, 2, 3, 4, 5, 6, 7. Like that you are going to define. If at all, if you want to know what do you mean by bit reversal mode means, say you have written 0 0 0. So if I am interchanging this position and this position, what I am getting is 0 only. But if I am interchanging this position and this position, what I am getting is 4. So I got it as 0 4 2 6 1 5 3 7. Now if you interchange this one, if you are interchanging this one, what you will be getting 0 1 0 only. You interchange this one, what you will be getting 1 1 0. First position and last position you interchange. What do you mean by 4 1 0 0? 1 0 0, if you are interchanging, it will become 0 0 1. 1 0 1 will return as it is 1 0 1 only. 1 1 0, if you are changing, if you will be getting 0 1 1. 1 1 1, if you are changing, this is 1 1 1. So this is actually what you mean by bit reversal. Bit reversal, first bit and last bit you are going to just reverse it. This is in the case of DIT FFT. This question they have asked. What do you mean by DIF FFT? DIF FFT. So in the case of DIF FFT, input is in normal form. Input is in normal form. Output is a bit reversal. Output will be bit reversal. Output will be bit reversal. That one graph is there, right? That butterfly diagram. Sorry, that butterfly. Sorry, that butterfly diagram is important. That butterfly diagram is important if you are preparing for GATE exams as well as engineering service examination. And that topic is DFT. So that topic is DFT. So this completes your signals and systems. Miscellaneous things I am going to talk about maybe on 4th of September. 4th of September I am going to talk. If you want to know like DIT FFT in further, if you want to know DIT FFT in further, say suppose if I am taking n point DIT FFT, how I will be getting, say suppose if I am drawing for like a sequence of 4, how I will be getting is you have to take or you want to draw 4 lines here. Then you are going to draw one more 4 lines over here. Draw one more 4 lines. This kind of questions you will be getting in UGC NET. No, calculator is not allowed. They will not be getting. How you are going to draw x of 0, x of 4, x of 2, x of 6? Because bit reversal. Because bit reversal. Input is bit reversal in nature. But what is the output you are getting? Before to that, you have to write the butterfly diagram. Sorry, butterfly structure. Butterfly structure, you will be having this value as W8 of 0. And this value is W8 of 0. Like that you have to replicate. Like this you have to replicate. Again, next stage will be like this. Next stage will be like this. Here you have to go for like this. This is minus 1. This is minus 1. What is this value? It is W8 power 0. What is this value? W8 power 1. Similarly, you have to draw in the bottom also. What is this one you will be getting? You will be getting like this. You will be getting like this. Here also you will be getting like this. It is something like you are drawing some Rangoli kind of thing you will be thinking. But if you are preparing for GATE now, this is must and should. You have to remember. And if you are preparing for engineering service examination now, you should draw neatly. You should draw neatly. Without any mistakes you should draw. So this is minus 1, minus 1, minus 1, minus 1. What is this value? It is W8 power 0, W8 power 1, W8 power 2, W8 power 3. What is the sequence you are getting at the output? It is x of 0, DFT, x of 1, x of 2, so on to x of 7 you are getting. What at max what they can ask is, at the input side if you are making use of trivial factor, then it falls under DIT FFT or DIF FFT. Yes, it is DIT FFT. In the case of DIF FFT, it will be falling on the output side. This block is there, no, you are going to write it at first. This one you are going to write it at last. This is the basic difference between DIT FFT and DIF FFT. And then you are going to talk about twiddle factor, that's it. So this completes your basics of signals and systems. And this one Laplace is there. Laplace, that one anyway we are very much familiar. Whenever you are having unit step, take it as 1 by s. Whenever you are having ramp, make use of 1 by s square. And parabolic 2 divided by s cube. And right of the right pole, left of the left pole, all those things we shall discuss later. Right? Till now, if you are having any doubts, please let me know.
Sir, in FIR filter. In FIR filter,
okay,
we use it for linear phase response, right?
Yes.
So if we are not having linear phase response, then what is the problem in the system?
if you're not
Like why we put linear phase?
see, if you're having like, if you're just making use of FIR filters, you will be getting a linear phase response. If you are making use of FIR filter, nothing but output is function of only input. If you are taking, then definitely you will be getting a linear phase response. If it is function of output, then only you will be getting like non-linear fashion. So based on input, linear or non-linearity define. You are going to define.
No, sir. If a system is not having linear phase response,
Then
in that case,
if the system is
we'll
not
get distortion.
no, what I'm telling is, if you are having, or if your output is depending only on input, then you will be getting a linear phase response. Say suppose if output is a function of input and past output, then you will be getting a non-linear system. That non-linear system you classify into as like a IR filter, or you just drop it into IIR filter. That's it.
Okay.
So what actually you're going to do is two kind of filters you're going to use. Whether you want IIR filter or FIR filter is left up to you. Complexity you want less, go for IIR, but stability you can't guarantee. Complexity you want more, go for FIR, but stability is guaranteed. Their trade-off lies between complexity as well as stability. Complexity or stability. Always there exists a trade-off. Always there exists a trade-off. So this is one thing what you have to remember. Want one, you are going to lose one. That's it.
Sir, and when in case of that odd even symmetry you talk.
Odd even symmetry. Yes.
So here, like to the left hand side of 0 and to the right hand side of 0, we are having like 3 numbers. So how it is odd, like how it is even symmetry?
Even symmetry means what? This value is 1.
Total.
No, this value is 1, this value is 2, and this value is 3. Now this is your, 1 minute, let me plot this one. How you will be getting in terms of like waveform? If I am drawing at a 0, it is 0 only. At 1, what is the value? It is 1. At 2, what is the value? It is 2. At 2, it is 2. At 3, it is 3 only. At 3, it is 3. At minus 1, what you are getting? It is 1. At minus 1, you are getting 1. At minus 2, you are getting 2. At minus 3, you are getting 3. At minus 3, you are getting 3. Is it not even? Is it not
Yes,
even?
sir.
Yes, it is even. Say suppose if it is
Okay.
if it is minus 3, minus 2, minus 1, 0, 1, 2, 3. What is the graph you are getting? You will be getting like this. You are
Yes,
getting,
sir, odd.
yeah, you are getting like this. First quadrant equals to third
Okay.
quadrant. What you will be getting? Odd. So this is one thing what you have to do.
Okay.
Others, any doubts? Thank you for being on my channel. Please like the video, share this video with your friends, and subscribe to my channel Craving Gyan. All the best for your competitive exams. Thank you.